Hi everybody, my name is Arthur. I'm a product manager at Aiven, looking after the ClickHouse service, and I'm here to discuss with you the journey from product discovery to the benefit and use cases of leveraging object storage for ClickHouse workloads and how we made tier storage available for Aiven for ClickHouse. We're going to go over what ClickHouse is, what ClickHouse as a service entails, what is the main problem that we've encountered, and the solution tier storage and why is it a fitting solution. So what is ClickHouse? A lot of you may be familiar with it by now, but basically ClickHouse is a very high performance column-oriented SQL database management system for OLAP, for online analytical processing. It's been developed by Yandex. It's been open source since 2016. Why is it gaining a lot of momentum right now? Well, first of all, it's column-oriented, as I mentioned. So that means all the data is physically stored on disks next to each other by columns, right? By similar data types. And so because of this, we can use very, very good compression codecs that ClickHouse has to apply the same compression to the same type of data. And as a result, ClickHouse is very, very fast. It's super fast. It's also SQL based, so lower barrier to entry. If you're using PostgreSQL, making the move to ClickHouse is not going to be a problem. Most of the data scientists already know a lot of SQL. You can read and comprehend what you're looking at. It's also a distributed database management system, which makes it a fit for analytics at scale and very big workloads. And it can talk to pretty much every technology that is out there. So no matter what tech stack you're using, you can take advantage of ClickHouse, and you can just spin up a ClickHouse on your own and make it talk to your data and start doing analytics. So ClickHouse as a service, well, who used this? I alluded to already, but anyone with analytics workload that want either very high performance, we're talking sub-second latency. For example, if you want to do analytics and you're giving it back to users, you don't want them to wait. Or if you want to do queries over large amount of rows, and we're talking billions. If you want to go above the second, you can, but you can still read billions of rows, and that makes it very interesting to for analytics at scale. And all of this, no matter where your data is. In this process of product discovery, we discovered that also some users failed to use ClickHouse. And what was that? Well, there was no compelling story. So not to go into the detail, but Aiven's architecture is not serverless per se. And so we have our cluster nodes and our VMs with each defined amount of storage of CPU. And we came to a point where, okay, what are we going to do? We have some clients that run proof of concepts, but how can we ensure when they 10x, 100x those workloads, it is still going to work at scale? And this is because we had a main problem that storage is a finite resource, right? This leads to three other more granular problems. The first one is scale. Here you can see typical Aiven architecture. You have your cluster nodes, you have your storage. This is your ClickHouse. Well, what are you doing when you want to have more storage? You increase the local storage of each cluster node. But then, as you can see right here, you hit the red zone. You can not just add more, right? At certain point, your cluster node is going to run out of local storage. So what are you going to do? Well, you're going to add another cluster. And this comes with a lot of problem of rebalancing, etc. So we need to make sure we support use cases of any size, but storage cannot scale independently. Second is the cost. The local storage is great. It's very performant. It's very fast. But SSDs can get very expensive, and our solution to scaling should not come at an additional cost to our customers. And third, we have performance hit, as I alluded to. If you add other node, you have rebalancing. If you have already a lot of data in your local storage, well, this is gonna mean a lot of performance hit for the whole cluster. Your workloads are going to be impacted. Errors also can be very costly when pushing the local storage too hard because, well, when you lose a node, you have more data on this node, so you are more at risk of losing more data, and this is never a good thing. So we are in need of a more elegant solution, right? We cannot just add more cluster nodes, add more storage to the VMs. We cannot just brute force it. So we kind of thought we need to think outside the box, and we came up with tier storage, and we realized that it was a fitting solution for us. So before I tell you what tier storage is exactly, we kind of had a look at the read patterns and the data access patterns, and we saw that most of the reads are done on new data, right? If you have a business, you have a website, you want to see what people are doing, what your users are doing on your website, you might want to look at the past few hours, the past day, past 3 days, 7 days. But if you've been in business since 2017, you've accumulated a ton of data that, yes, maybe you're going to still use when you do the year-over-year comparison of traffic, for example, or some yearly aggregates. But those are going to be 1 or 2 charts in your report. They're not going to be most of the reads. And so this older data is going to be less accessed than this new data. And so tier storage is letting the user split their data into 2 tiers, one hot, one cold. The hot one is for all the mission critical data, and this data is going to live on high performance local disk. And the cold data, less accessed, but that you still want to keep for a compliance reason or because you want to do those year-over-year comparison, for example, they are going to live on remote disk on object storage. This is how it looks like. If you remember here, the local storage is not in the red zone. It's kept at a reasonable amount. You can still increase it if you need. You can still lower it if you need, but we've added remote storage to each and every cluster node. And this remote storage is great for 3 reasons. If we take again those 3 problems that we had, well, for scale, first of all, object storage is potentially infinite scale, right? You're not bound to the VM, you're not bound to your specs. So this is a very, very compelling scaling story. About cost, object storage is cheaper relatively than SSDs. So this comes with a lower cost than just adding more machines, adding more SSDs. And well, performance, you are still keeping your hot mission critical data on disk. So you're not making any compromises on why you're using ClickHouse, and those sub-second latency queries you can still have while not making any compromise in terms of what data you retain. So no noticeable performance hit when using object storage. Okay, let's wrap up. Tier storage is a fitting solution that we came up with by looking at our architecture at Aiven, our adoption problem, and ClickHouse's possibilities and advantages. Leveraging object storage makes it possible to use ClickHouse at scale while not making any compromises on why you're using ClickHouse in the first place. That's great, no? We knew it was possible to scale ClickHouse since very large companies like Uber or Cloudflare are already using it for their logs or their analytics workloads. But we really cracked the code at Aiven with tier storage and its exciting capabilities. Thanks for listening,